kilogram tugboat is towing a 50,000 kilogram ship in a northeasterly direction, while at the same time an identical tugboat tows in the direction north 10 degrees east. Each tugboat's engine is rated at 10 kilonewtons. What is the magnitude and direction of the ship? Okay, so we have our ship here, and this is a 50,000 kilogram ship, and there's one tugboat here pulling it northeasterly. Okay, and then there's one pulling it at an angle north 10 degrees east. It's there, and they both tug at 10 kilonewtons, and both of these tugboats are 5,000 kg. And they both can pull at a force um, 10 kilonewtons. And this angle here is 45 degrees, and this angle here is 55 degrees. Yeah. No. This angle here is 10 degrees, so it means this bigger angle here is 80 degrees. So that one's 45, and that one's 80. Okay, so we'll have to resolve here. This will be 10,000 cos 45 from the northeasterly tugboat, and also the east component here of the other tugboat, which is 10,000 cos 80, and likewise here this will be 10,000 sin 45 plus 10,000 sin 80. So let's get those two forces first. So the lower one, 10,000 in both cases, so we'll take the 10,000 out, and it's cos 45 plus cos 80 times 10,000, so that's 8808. And then sine 45 plus sine 80 times 10,000, so that's 16919 in total then. Okay, so we have F equals ma. Now the F here is a total force acting on the ship. That's fine. And the acceleration, I think, is what we're looking for. Yeah. So the question here is what to use for m. So that is m equal to 50,000 or 50,000 plus 5,000 plus 5,000. Well, let's just have a look here. Imagine we're the ship for the moment. We see our mass as 50,000, and we have two tugboats tugging at us, but we don't necessarily know that the tugboats, all we feel is two forces tugging at us. So these masses here, they're not really considered into the mass of this problem, but in some situations we do have to combine the masses together. But usually in those situations we're looking at the system as a whole, like for example the train here, In this case, obviously, if we had a train, we have to consider all the carriages. That's because we're looking at the whole system moving off together. Whereas here, we just really care about the original ship. So I know this can be a bit confusing, which mass do we take and which force do we take, but in this case, it's almost like these masses and ships don't exist, and all we look at and care about is the force that's tugging on this ship here. So, let's look at the two forces here. So, horizontally, A would equal F over M, which would be 8808 over 50,000. This would be the acceleration horizontally. .17616, and then likewise vertically it would be 16919 over 50,000. That's 0.33838. So let's get the net acceleration here by using the magnitude of this vector, and then we can get the direction as well. So in total, the acceleration would be 0.17616 squared plus 0.33838 squared. So that's 0.381, we'll say, meters per second squared, and the angle .33838 divided by 0.17616, 62.5 degrees. So that is east 62.5 degrees north. Okay, so our final answer here is that the ship will accelerate at 0.381 meters per second squared in a direction, the acceleration is in the direction of east 62.5 degrees north then. So this is a hard one now.